In 1600, the English scientist William Gilbert suggested that the Earth contained a great magnet. Was Gilbert right? We know now that he was, in a way. The Earth is surrounded by a magnetic field, and it's not the only planet with a magnetic field. Other planets have them. From this table, you can see that all the planets of the solar system have a magnetic field, although, for example, the magnetic fields of Mercury, Venus, and Mars are extremely weak. On the other hand, the magnetic field of Jupiter is so strong that scientists think it may prevent living organisms from growing. One of the most spectacular consequences of a planetary magnetic field are auroras. This is the aurora in our skies near the North Pole. This is an aurora on Jupiter, and this is on Saturn. How can we explain the origin of auroras? Let's begin by saying that the Sun expels an enormous amount of small particles every second, and most of these particles are electrons or protons. This stream of particles is called solar wind. Magnetic fields interact with charged particles in motion in the solar wind and bend their trajectory. The magnetic field lines of the Earth channel many charged particles, that is to say, electrons and protons, in the polar regions, and these particles accelerate so much that they emit light. Solar wind can be very dangerous because it contains particles with a very high energy. These very energetic particles can damage our DNA. Luckily, our magnetic field acts like a shield and protects us from the solar wind. In other planets, where the magnetic field is very low, such as Mars, the surface receives much more radiation and the risk of damage to our body is very high. Here are a few more things on the magnetic field of Earth. First, the magnetic north and south poles are not in the same position as the geographic north and south pole. There is an angle difference of about 10 degrees. Second, the magnetic poles change position every year. They move. We say that they drift over time. Third, every few 100 million years, North and South poles quickly switch position, and no one really knows why. Finally, why do planets have magnetic fields? The most credited theory is the DYNAMO theory. The interior of our Earth contains liquid metals. These metals are said to be ionized. That is to say, the electrons in these metals are separated from their atomic nuclei. So basically, it's full of electrical charges in motion. So it's like if there is an electric current going round inside the Earth. And as we will see, electric currents create magnetic fields.